All right, this is Unit 5, Video 16, Theoretical Yield and Limiting Reactant. When we calculate the product produced, it's called the theoretical yield. We want to determine now which reactant in a pair of reactants is the limiting reactant. Now, the concept of limiting reactant is pretty straightforward. If I have a candle and I put it out, light it, let it burn, it'll eventually go out. It goes out because the candle wax runs out. Now, in the past, we've said in calculations that the calculation is done in excess, in the case of the candle, in excess oxygen, meaning there's plenty of oxygen. It will not run out no matter what. That's what we're guaranteeing. So we've really done these limiting reactant problems already. The candle wax is a limiting reactant, so I only need to do a calculation with the amount of the candle wax. I could weigh it out beforehand, weigh the wax, determine the number of moles, and figure out exactly how much carbon dioxide and water is produced in the reaction. Now, if I took that same candle and I put a cup over top of the flame, you know the flame will go out. Because now I've switched the limiting reactant and forced oxygen to be the limiting reactant. There's plenty of candle, but it goes out, so the reaction ceases. That's because the oxygen runs out. So the limiting reactant is simply the reactant that runs out in the reaction. When that happens, obviously the reaction has to stop. Now, we're going to calculate the limiting reactant by taking the mass of two different reactants in a reaction and determining their theoretical yields. So I have a reaction here. Ethylene, combusting. That means it's reacting with oxygen, producing carbon dioxide and water. So that's our balanced reaction. Have to have a balanced reaction to do any stoichiometry calculation. 4.95 grams of ethylene combusts with 3.25 grams of O2. So I have data for two reactants. That's the way I want to look at that. So I can say, okay, here's a reactant and here's a reactant. I'm going to take that data and calculate the theoretical yield twice. So I don't want to think, I'm not going to use these together. I'm going to do one calculation to CO2, stop, then I'm going to do another calculation to CO2, then compare the two. So let's look at that. I have 4.95 grams of ethylene, C2H4. I'm going to convert that into moles of ethylene. Ethylene has a molar mass of 28.06. At that point, I have moles of ethylene. I don't want moles of ethylene, I want moles of CO2 because I'm predicting the theoretical yield of CO2. So I'm going to put CO2 on top, ethylene on the bottom. What I have goes to the bottom, what I want on top. This is coming from the balanced reaction. I have a 2 there and a 1 there. At that point, I have moles of CO2. I've converted from my moles of what we call A, which is C2H4, to my moles of B, which is CO2. CO2 has a molar mass of 44.01 grams per mole. Okay, so I'm going to do this calculation. When I do this calculation, I'm going to get 15.5 grams of CO2. So 15.5 grams of CO2 will be produced if all the ethylene is consumed. That's all we need, is all the ethylene to be consumed. Well, that might happen, it might not. Let's figure out. So let's take our oxygen here, 3.25 grams. We'll convert it into moles. Now I'm taking the oxygen and still going to CO2. Both of these must go to the same quantity so I can compare them. So I'm going to go through and say, okay, there's, what, 3 oxygens for every 2 CO2s. At that point, I've converted to moles of CO2. I want to calculate moles or grams of CO2. So I'm going to go 44.01 grams per mole. Plug that through the calculator, and I'm going to get 2.98 grams of CO2. At this point, I'm going to compare the two. So I want to do a comparison here. When we reach 3 grams, basically, of CO2, the reaction's going to stop. Because at that point, the oxygen has been consumed. The reaction could have gone to 15.5 grams of CO2 if I gave it enough oxygen, but I didn't. So what we're going to say is the O2 is the limiting reactant. That means that C2H4 is the excess reactant. And the true theoretical yield is not 15.5 grams, it's 2.98 grams.